Hi everyone. In a previous video I said this. To do some coding, let's build a neural network. Alright, finished. Well, that was easy. Well, spoiler, it really wasn't as easy as it seems in that video. What I thought we'd talk about today is the logic behind the neural network and why it can sharpen images. Welcome to Deep Sky Detail. Okay, before I get into how the tool works, I thought I'd break down how some neural networks work with a simple example. Let's pretend that you want to figure out how tall children will grow up to be. One thing you could do is to take a whole bunch of things you know about the children that you think would be related to how much they grow. These things could be their parents' height, the parents' income, birth weight, etc. What we want to do is make a prediction based on those numbers. At a fundamental level, a neural network takes real numbers and transforms them several times to give us a possible outcome. On the right is a graphical depiction of a neural network. We'll call the circles nodes, and the lines connecting them connections. The connections show how nodes are related, meaning whether it can affect another node. Neural networks have three main types of nodes. The input nodes are the real-world numbers we know, like the parent's height, the income, and hidden layer nodes, and an output node, which is the thing we want to know, in this case, the future height of the kids. You start out by transforming an input node, like a parent's height, and multiplying it by a number. You can think of the first transformation as a number that gets temporarily put in the first node of the first hidden layer. You repeat this process for each node in the next layer. This process then repeats for the next input node, and the next, and the next. At some point, you've transformed and multiplied each of the inputs for as many nodes as there are in the hidden layer. In our case, each node of the first hidden layer now has 9 numbers associated with it. Those 9 numbers get transformed, maybe you add them up, to get one number. You can then think of this new hidden layer as an input layer for the next hidden layer, and you repeat the process to get the numbers for the next hidden layer. This continues until you get to the output node. Now you're probably thinking, how does the neural network know how to transform and multiply things? The answer is you have to train it. In our case, you would need to have real-world data where you know each of the 9 input values of adults when they were kids, plus the height of the adults. You would then have the neural network guess what to multiply each of the inputs by and have it spit out a random prediction. Then you'd tweak the multiplication values a bit and see if the model improves. You'd keep doing that until you're satisfied with the predictions. And voila! You've trained a neural network that can be used with new data. Alright, but what about a sharpening tool? How did you create that? Well, poorly probably, but if you'd like specifics, this is what I did. Let's say we're going to take a picture of a star in a perfect world with no atmosphere and no distortions from your optics and perfect tracking. If this is a zoomed in image of your sensor in that theoretical world, and each square is a pixel, then the white square would be the star. Crazy, right? Stars are so far away that they're basically point sources of light. Theoretically, they'd only be hitting one pixel. Well, unfortunately, we don't live in this theoretical perfect world. If we were to take a slow motion video of the star, it would probably look something like this. Photons would be bouncing all around the sensor because the atmosphere is bending the light sporadically. Your telescope mount isn't perfect, and a whole bunch of other things are making the light hit the sensor in different places. During a long exposure photograph, the pixels surrounding the target pixel would start lighting up as well. The result is a blurry image. To get a feel for how the atmosphere distorts the light, here is a video of the moon taken with my Celestron C8. It's almost as if the atmosphere is some kind of fluid. Note, yes, that is sarcasm, air is a fluid. So what do we have? Well, we have a target pixel from a perfect world, where the star would be, which we'll call the output, and we have the surrounding pixels of a blurry image, which we'll call the input. Now, where will we get pictures from? If only there were some awesome telescope in the sky that had great tracking and wasn't affected by the atmosphere. Enter the Hubble Space Telescope. Its pictures are almost perfect, and it's easy to make them less perfect, so we've got inputs and outputs. Okay, as I mentioned before in my previous video, I took Hubble pictures, made them blurry, and then trained a neural network. I actually created several neural networks with different types of inputs, until I ended up with one that I liked. Let's look at some of the results from trying to sharpen HA data of the Veil Nebula that I took. Well, I think that's it for this video. Be sure to like and subscribe and check out the Sharpening Tool. Link is pinned in the comments.